Greetings, everyone! A short while ago, NASA shared a collection of breathtaking images from the James Webb Space Telescope with the world. These visuals are nothing short of magical, offering us an unprecedented look at the mysteries of our cosmos. Within these frames, we are witnessing the oldest light ever captured, peering back 1 billion years into the history of the universe. Furthermore, we've pinpointed a distant alien world that shows clear signs of water. In today's video, we are going to dive deep into these monumental findings. As the most advanced and massive space observatory ever constructed, the Webb is redefining our place in the stars. Every photograph is a doorway to a new discovery, allowing humanity to gaze upon the birth of galaxies and the chemical signatures of far-off worlds. This 10 billion marvel represents 25 years of meticulous engineering and planning, and it is currently operating in the extreme silence of space at a staggering 266.75 degrees C, just a few degrees shy of absolute zero. To maintain such freezing temperatures and protect its sensitive instruments, the telescope doesn't circle Earth like the Hubble. Instead, it orbits the Sun at a special location called the L2 point, roughly 5 million kilometers away, where it stays tucked within Earth's shadow. A massive sun shield, roughly the size of a tennis court, protects it from the sun's heat. For the photography enthusiasts among you, consider this. While a standard L lens might have a focal length of 5 the Webb's focal length is a massive 131.4 meters. Its primary mirror alone weighs 705 kg. While I have covered the technical construction of the telescope in a previous video, which you can find linked below, today we are focusing on the incredible visual data it has returned. To understand these images, we must remember that the Webb looks at the universe through infrared light. While our eyes only see a tiny sliver of the electromagnetic spectrum, infrared waves are longer, allowing them to pierce through thick cosmic dust and gas clouds that usually hide stars from view. The telescope uses two primary eyes: the near-infrared camera for shorter wavelengths and the mid-infrared instrument for longer ones. The difference between them is striking. In one viral image of a dying star, NIRCAM shows us a brilliant, glowing cloud of gas, while MIRI's longer wavelengths cut right through that smoke to reveal two stars at the center orbiting each other. This is a planetary nebula, the final breath of a star. One star is vibrant, while the other is fading away, shedding its outer layers into space. This serves as a preview of our own sun's fate. In about 5 billion years, our sun will expand into a red giant, consuming Mercury and Venus, and eventually leaving behind a similar nebula. While Earth will become uninhabitable then, we have eons to figure out a solution. For now, let's look at the first historic image released, the Deep Field View of Galaxy Clusters SMATA 723. This image utilizes gravitational lensing, where the massive gravity of closer galaxies acts like a magnifying glass, warping and brightening the light of much older galaxies behind them. This single image is a composite of 5 hours of data, showing us galaxies that are redder and older than almost anything we've seen before. Moving on, we see Stephan's Quintet, a group of 5 galaxies. Interestingly, the galaxy on the far left is only 40 million light-years away and appears quite sharp, while the other 4 are 290 million light-years away and are actually locked in a cosmic dance, their gravity pulling and stretching one another. From the death of stars, we move to their birth in the cosmic cliffs of the Carina Nebula. This stunning landscape of mountains is actually a massive cloud of gas and dust where infant stars, visible as glowing red dots, are just beginning to form. But perhaps the most scientifically gripping data isn't a photo at all. It's a spectrographic reading of MIRI ASP 96b, an exoplanet 150 light-years away. By using the NIRCAM instrument to analyze the light passing through the planet's atmosphere, scientists found clear dips in the data that prove the existence of water vapor. Just as chlorophyll reflects green light on Earth, different molecules block specific wavelengths of light in space. By charting these missing pieces of light on a graph, we can confirm what an atmosphere is made of without ever landing there. While MASP 96b is too hot for life at over 530 GeG C, the search continues. There are an estimated 300 million habitable planets in our galaxy alone, though we have only cataloged about 5,000 exoplanets so far. One of the most promising candidates is TRAPPIST-Whiteheen, located 40 light-years away. It is remarkably similar to Earth in size, density, and gravity. It orbits an ultra-cool dwarf star at just the right distance for liquid water to exist on its rocky surface. In the coming months, the Webb will turn its gaze toward the TRAPPIST system to hunt for carbon dioxide, methane, and water vapor, the holy trinity of life-sustaining gases. We are on the verge of knowing if we are truly alone in the universe. I hope this deep dive into NASA's latest treasures was enlightening. If you want to learn more about the telescope's journey, check out my other videos. Until next time, thank you for watching.